Hello everybody, I will start my today with another coding practice. So in this video, I will solve this question, maximum product subarray. So in this question, I'm given an integer array nums, and I will find a subarray that has the largest product, and I will return the product. Okay. The test case is generated, so that answer will fit in the 2-bit integer. Okay, so I will be given the integer array nums, and I will find the subarray that has the largest product, and I return that largest product. Okay, so firstly, I try to clarify something in the question statement. So something I try to clarify first is if subarray cannot be empty or not. And the second thing I try to confirm is if the element is only positive or including 0 or including negative numbers. So that's what I try to confirm. Okay, so I will take a look. Yeah, so in this case, subarray is configured as non-empty sequence. So it cannot be empty. Okay. And from these examples, and also from this constraint, I can find that number can be negative, 0, or positive. Okay. So that being said, let me think how I can solve this question. Okay, so when I think of this, okay, let me go with simple example. In this case, the maximum product subarray should be 1 to 3, obviously. And let's say I have -2 here. In this case, the maximum subarray should be only 1, no, only 3. Okay, good. And when I think of this case, the maximum product should be maybe 4, obviously. But let me include something more. Oh no. Okay, let me do it in this way. So if in this case, it should be this 6. I see. Okay. So I will think of the algorithm. So when I first say, okay, so maximum product subarray. So I have 2 factors I have to think. The first factor is positive or negative. And the second, okay. So yeah, positive or negative. And the second factor is how big the actual integer is, product integer is, like 4 or 3 or 2 or something like that. Yeah. And I can say if the product sign is positive, then I should pick the largest actual, product. But if the sign is negative, then I should choose the smallest actual, integer, I mean absolute value to get the high maximum number. And one exception is 0. Yep. So once I include 0 in the subarray, at that moment, the subarray sum product becomes 0. So that's what I like to take care. And for example, in this case, 0 becomes the largest number. Yeah, because in the left hand side, I have -1, which is the product, and I mean sign is negative and actual number is 1. Yeah, and also I have -2, which is actually smaller than 0 because it's negative. Okay. So that being said, what I'm thinking right now is I will, split the array into subsections, excluding 0. Yeah. And out of these, ranges, I will try to find, yeah, the maximum and minimum. And if I'd like to make this absolute value as large as possible, I should take as many numbers as possible. And if I'd like to make it minimum, I should take as less number as possible. Mm. Yes. So, yeah. Oh, by the way, the brute force approach of this question is thinking of all the possible subarray and calculate the product for each and return the maximum one. The number of possible subarrays is n times n minus 1, so it should be n squared time. Mm. Okay, so, and that being said, I come back to my approach. So when I think of this, I will think of this in this way. So firstly, I start from -3, and then when I get -2, it becomes 6. Then it becomes 12, 36, and then -36. Even if it is -36, I should keep it. I should keep the -36 because say if I have -2, then it becomes 72, which is quite big number. Yeah. So that being said, one idea I've just come up with is I always think of the maximum, positive and minimum negative. Yeah. Because if the next number, I mean, if I have a negative number, then it should be multiplied by minimum of the negative number so far. And in that way, it becomes the biggest number. It may become the, no, it definitely becomes the biggest number. And if I have, say, one integer number, sorry, one positive number, then I should multiply it by max positive number. In that way, I can get the maximum number, maximum product. So what I mean by this is that say I have 2, 3, 4, then this number. Firstly, the maximum should be 2. Then maximum should be 6. Then maximum should be 24. And here, minimum should be 2, and minimum should be still 3. Wait. Yeah, correct. The minimum should be 4. So I'm thinking of the array which ends at this number. Yeah. Then when it comes negative 3, I multiply it by 24 and I get negative 72, which is the smallest number. Then I multiply 4 times negative 3, then I get negative 12, which is the largest number, which ends with negative 3. Then when I get negative 2, I will think of the maximum product, which ends with negative 2. So for maximum, I should because this is negative, I should multiply this with negative 72, and I get 144. And for maximum, I should multiply with 12 minus 12, and I get 24. No, I think in this case, no, this is correct. Yeah. Okay. Then when I get 2, because this is the positive number, to get the maximum number, I should calculate it, multiply it by 144, which is the previous max. Then to get the minimum, I should multiply this with the previous minimum, which is 48. Then I get 3, and I get it in this way. But I think for 3, it should be 3 times 2 is 6, and then this becomes negative 12. I think negative 12 is possible with this. I don't know why it isn't. Let me check. I see. So I think I had a choice that I don't choose from the previous number. I just use this number only. In that way, it can be negative 2. Mm. Yeah, now it makes sense to me. Then when I got negative 1, to get the maximum number, I multiply this with negative 12. And to get minimum number, I get this. And when I get negative 2, yep, I will take a look at this, and I get this and this. Okay, so let me quickly, summarize my idea. So yeah, obviously I can use dynamic programming for this question. And for each dynamic programming, the problem I'd like to solve is, given the end index, what's the largest product which ends with that index? So that's a problem I'd like to solve. And if I solve this question for each end index, then out of those numbers, I get the maximum one, global maximum one. Yeah. And that being said, to solve this question, I need 2 things. Which is the maximum product which ends with one index before, and minimum product which ends with one index before. So these are the subproblems I'd like to solve. And with the result of these subproblems, I can solve the original problem. So this is obviously the dynamic programming. Okay. So that being said, I will quickly write something here. So basically, I will think of this and this and also this. Okay. So when I showed it in the example, I, distinguished the case when number is negative or number is positive, but actually I can generalize it in this way, obviously. Yeah. Okay, so this being said, let me work on the implementation. Yeah, I will take the first number and put it as the global max temporarily. This global max will be updated in the dynamic programming steps and eventually returned. So for the, base case, it should be to the first element. Okay, from here, I will calculate. So these are three candidate numbers of the minimum product, which ends with index I, or and maximum number, which ends with index I. Okay. Okay, let me name it in this way. Okay, so in this way, I get min product and max product, which ends with this index I. So I update global max with this. Okay. Then in the end, I will return global max product. Oh, and as I said, I forgot the case of 0. So if 0 occurs somewhere, all of these minimax candidates become 0. Yeah. And mini product and max product will be 0. This is correct. And the number which comes immediately after 0, if it is negative, sorry, if it is positive, then yeah, mini product should be, because yeah, this and this should be 0. So the candidate should be 0, 0, and that number, say 3. So in that way, mini should be 0 and max should be 3. Okay, sounds good. So actually, I think I don't have to, distinguish number 0. I mean, I said I will, makes a segment with, split the array into sub-arrays with index number zeros as the diameter, but I think I don't have to do it actually. This code covers that case. So that being said, the time complexity should be O of n and space complexity should be constant. Okay, I will think of this case. In this case, I first initiate global. Okay. Let me do with this. No, let me do with this. Okay, firstly, I initiate global max product with 5. Then in line 36, n is 4. And mini product max product is 5 and 5 now. Okay. Then in line 39, yep, I iterate from n is 1 to 4. No, 1 to 3. So firstly, in line 4 candidate should be um 5 times, now current number is 0, so 0, 0, and 0. Yep, all of them should be 0. Yes, this is correct. So mini p is updated with 0, and max p should be initiated with updated with 0. Okay, the next thing, oh, and I don't update in line 49 global max product because it's already 5, which is larger than 0. Okay, now I come back to line 41 and I will take a look at number minus 2. And with number minus 2, the candidate should be 0, 0, minus 2. Yep. So the number which the largest one is 0 and minimum one is -2. Okay. So mini product is 0, max product is, so mini product is -2, max product is 0. And then global max product is not updated now. So I go back to line 42, and now this is the last index, and nums I is -3. So the candidate becomes now -2, 0, and -3. So 6, 0, and -3. And now, so the biggest number should be 6, and minimum should be -3. Yep. Good. So now global max is updated with 6. So I return 6. Okay, this is correct. So it seems like, yeah, indeed, I don't have to take care of the numbers of the 0. I don't have to, split the array with diameter 0 because, yep, I have the choice that I don't choose zero, previous zero, but choose only the current number. That would work. Yep. Okay, so I execute my code. Good, accepted. And I submit my code. Great. Okay. So I quickly wrap up on today's practice. So today I solved the question maximum product subarray. So in this question, I'm giving an integer array nums and find a subarray which has the largest product. And I will return the product. Okay, so in this question, I solved this with dynamic programming, bottom-up approach. And I thought of the maximum product, which ends with each index, and I return the maximum one out of them. And to think of this, to think of the maximum product, which ends with index I needed to result of the subproblems, which is I will think of the product which ends with index previous index I minus 1, and I will think the minimum product of that and maximum product of that. And that once that is answered, then I can find the product, the candidate of the product, the candidate of mini or max product of index I should be nums I or nums I times, nums I times mini of, yeah, previous one, or nums I times max of previous one. Yep. So I compare these three numbers and I guess, yep, mini product and max product, which is the index I. Okay, that's the basic approach I can use. So I finished my today's coding practice with this. Thank you so much. Bye.